What's going on, guys? In this video we are going to see how to find general solution for an exact differential equation. Now the standard form of exact differential equation should look like this. That is m of xy plus n of xy dy over dx is equal to 0. And if you look at this one, we have that form, but still we are not sure whether this is exact or not. To prove this one, what we have to do is we have to find the partial derivative. So this is our m of xy. From the pattern you can recognize this is our m of xy and this is our n of xy, right? And then what we do is we take the partial derivative of m respect to y, and we take the partial derivative of n respect to x and see whether we are getting the same values, same equations. And if we get the same answer, it means this is an exact differential equation. Now let's go ahead and find the derivative of this one respect to y. And when we take the derivative respect to y, we treat x as a constant. And here if you treat x as a constant and find the derivative of this one, this is going to be minus 2xy power minus 2. And here this y will become 1, right? When we find the derivative, this will become 1 and other things are going to be just constant. So this is going to be 2 e power 2x and minus 1, this is going to be 0. Now this is our partial derivative respect to y, and let's take the partial derivative of this one respect to x. And when we take the derivative of x, we treat y as a constant, and if you take the derivative of this one, that's going to be 2 e power 2x, and this is going to be 0 since we treat this one as a constant. And here we have negative x squared, and that's going to become negative 2x, and y power minus 2, we treat that one as a constant, so this is going to remain the same. So if you notice, in the left m of y and n of x, we are getting the same value, right? Negative 2x y minus 2, negative 2x y minus 2, 2x 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 2 e power 2x 2 e power 2x. So both of them are same. Therefore this is an exact differential equation. Now we can go ahead and solve for we can find the general solution. To find the general solution, what we do is we take this m of m and integrate this one. Like we can do there are two different methods. You can integrate this m of xy respect to x, right, m dx, or you can integrate this one n respect to y, and then you can solve it. But we have to look at which one is going to be easy to integrate, and here both of them almost easy, so we can just choose one of them. Let's choose this one. Now we are going to integrate m of dx, this one m respect to x, and if you integrate this one, that's going to give us 2x squared divided by 2. That's going to give us just x, right? Because 2 cancels. X y power minus 1, and then here we are going to have 2y e power 2x. So e power 2x, if we integrate this one, that's going to be e power 2x divided by 2. Again 2 cancels, so we are going to left with y e power 2x, and minus 1, if you integrate respect to x, we are going to have an x right here. So this is going to be x. Now we have only integrated x. Since we have y and x, we only taken care of the x values. So for y values, but we, instead of putting constant right here, we put this one plus a function respect to with a related to y. So let's say h of y, and after that what we have to do is, now we have integrated this one respect to x. Now we have to find the derivative of this one respect to y. So let's go ahead and find it. And if you find the derivative of this one respect to y, so let's call this one psi y, right? And if you find the derivative of this one respect to y, we treat x as a constant, and this is going to be minus x it's look like I made a mistake right here. I integrated this one, but I forgot to put a square right here, because when you integrate, it's going to be 2x squared divided by 2, 2 cancels, but we have an x square, right? So this is going to be negative x square and y power minus 2. We are integrating this one, finding the derivative of this one respect to y, and this one is going to be respect to y derivative. This is going to be just e power 2x, right? E power 2x, and this is going to be minus 1 and plus h prime of y. So this is what we are having. This is, I'm finding the derivative with respect to y. This is constant, this is 0, right? This shouldn't be here. So we put plus h prime y. So this is going to be the derivative of this one respect to y. Now this is the final answer, but the only thing we have to find is we have to find h prime y. We have to find it out and then plug it in this equation. We have to plug it in this equation. This is our answer pattern, the first one, that we found our derivative with respect to x. Now we have to find h of y and plug it in this equation. Now to find that one, what we do is, this derivative is, we are going to equate this one to n of xy. So if you notice, minus x square y power minus 2 plus e power 2x plus h prime y is equal to n of xy. N of xy is this one, right? E power 2x plus y square minus x square y minus 2. And if you notice from this one, we have these terms similar and these terms similar. Therefore h prime y, h prime of y is equal to y square. Now to find the h of y, we integrate this one respect to y. So if you find an integration respect to y, this integration and derivative cancels each other, but I have to do integration other side too, dy, and if you integrate this one, that's going to give you h of y is equal to y cubed divided by 3 plus constant. Let's put a k right here. Right, now what we are going to do is, our final answer is going to be this one. We are going to replace this h of y, and that's it. So, and replace this one, and we also have to write this one. If this is our f of x, we have to write f of x is equal to c. We have to equate this value to a constant. Now let's go ahead and do that. So this is going to be c is equal to x square y power minus 1 plus y e power 2x minus x, and we know the h of y is this one, right? Y cube over 3 plus constant, k. Now we can combine these two constants together and write it as a big C. Like if you say this is C1, let's call this C1. So C1 minus k is equal to C. Therefore C is equal to x square y minus 1 plus y e power 2x minus x plus y cube divided by 3. And that's it. This is going to be the general solution for this differential equation, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.